All right, I have hit record. Let's start going through some stuff. So in our book, the data one, on the cover it talks about pandas, NumPy, and IPython. We've talked about NumPy already, the NumPy arrays that we loaded data, created data, and all that kind of stuff. Tonight I'm going to start talking about pandas. We have two topics for tonight because we didn't have last week, so bear with me. Let's start talking about pandas. It is a way of manipulating that data. And to do that, we're going to start playing with an kind of open source data set. So from this Kaggle website, they have a whole bunch of different data sets, which are kind of neat. But you have to log in, create an account or something like that. But from here, you can get data. So the trending YouTube video statistics, COVID-19 research open data, Pima Indians diabetes database. So you can get all kinds of cool stuff. So what I did, I looked through and I found something that I thought would be easy to talk about and explain. And so I went to movies. So if you get the movies data set, you'll get a whole bunch of files. Reading some of this description, the files contain metadata for 45,000 movies in the full movie lens dataset, whatever that is. TMDB vote counts, vote averages, cast crew, plot keywords. So there's a whole bunch of different data in here. 1, 2, 3, 4, 5, 6 files with data, so 6 data sets. So we're going to play with that. So I downloaded the zip file. And to start, I unzipped all the files. So I opened them up, and so I ended up with movies metadata.csv, credits CSV, ratings CSV, and I think there are a bunch of others. So to use pandas, it is another Python library, just like NumPy was, or a lot of other stuff we've talked about this semester. And so I'm going to go through slides. These are slides coming out of Jupyter Notebook, so they'll look like Jupyter Notebook. The actual notebook is in my GitHub with the slides if you want to follow along at home. So let's look at the movies metadata.csv. So in pandas, we have a nice function called read CSV. Makes it really easy. So that actual file, let's see if I can get that actual file. Nope. I guess I don't have the file in the CSV. Whoops. We'll make that happen later. So I can run this read CSV and it'll open. If you get an error, just kind of ignore it, or a warning, I should say. This one's a data type warning. And we'll talk about what this means in a little bit. But anyway, pandas, we imported pandas as PD, like the NumPy of NP. We've aliased pandas as PD, so we can call all the pandas functions. And we'll read the movies metadata CSV. So I'm going to go back and forth. On this line, you'll see I created after reading the CSV, I created a movies variable and assigned the read CSV to that movies variable. So if I use Jupyter Notebook to tell me things about movies, it prints it out in a pretty cool format to show me the data associated with that CSV file. So we can see I have columns like adult belongs to collection, budget, genres, homepage, ID, language, original title. I have a whole bunch of data. And you can see a mixture of data types. I've got a bunch of strings. I've got some floats, strings. I saw JSON over there somewhere. Looks like a little JSON string. So I got a whole bunch of different data types in there. So the movies, using Jupyter Notebook and printing out a pandas data frame shows you, I think, the first 5 and the last 5, first 10, last 10, something like that. But you can see I've got over 45,000 records in this table, in this data set. So there are some functions, and we like to talk about functions available to us in these data structures. We have a head function that in this case takes an integer parameter on that data frame, and it returns the first, in this case, 8 records, index 0 through 7. But that's it. I didn't change anything else. So that's one way to get some of the data, just to kind of inspect it. Oops, wrong way. There's a dtypes attribute that we can see what data types are in each field. So the adult field is an object, belongs to collection is an object, a whole bunch of objects. Strings become objects, dictionaries become objects, that kind of stuff. A couple of them were floats, more objects, and 2 more floats. Object is kind of the generic data type. What Pandas tries to do is look at the data, in this example, the CSV. It's trying to load that data in the CSV and guess at what the data type of that column is. So something like genre, we would expect to be probably a list of strings. That makes sense? An ID, I would expect it to be probably either a numeric ID, in which case these should be either a float or an integer data type. But Pandas classified it as an object, which probably meant, actually that's what that error meant before. This warning says this column has mixed types, meaning it can't say definitively this column only has floats. So that's where this message comes from. So first thing not written down in slides. When we do data analysis, step 1 is clean your data. We haven't cleaned our data, but that's okay. If we had cleaned our data, then all of these fields would be properly typed. There is a nice built-in toExcel function. So if I wanted to read that CSV, then I could output it to an Excel file, specifying what sheet it is and whether to put out an index or not, whatever that means. So if you run this, you get an Excel file. And then you can use that in Microsoft Excel. Now, that's a really inefficient way of transforming a CSV to an Excel file, but after we learn the rest of the stuff about Pandas, then it can make more sense. All right, so there's another function called infos on our data frame. So the variable here is a data frame. That is the data type of that variable, like we saw in NumPy arrays before, or dictionaries or strings, whatever. This is a data frame. In this one I have 45,466 records from index 0 through 45,465. There are 24 columns on each of these records, and those columns are what we just talked about. This shows me a list of the available data types, and it shows me how much memory is being used. So really helpful information if you're trying to figure out how to process all your data. And Caitlin, did I answer your question? The adult column looks like a Boolean, but it became an object. That's because it has multiple. It couldn't determine that it's a Boolean. But yes, it should be a Boolean. So the head function again, we can call it without a parameter, and it looks like it returns the first 5 rows, but all the columns. Now I can start pulling pieces of data out of this. So if we look at this syntax, it looks an awful lot like pulling a key from a dictionary. So the movies is my data frame, and one of my columns was called original title. And so I'm pulling all of the original titles into a new variable called titles. And when I print out titles, I get a list of my titles. Now this is not this is not another data frame. This is a series. It's another data type or another object. It is a series which has different attributes and different functions available to it. Now, my titles has a shape. In this case, it's one column with 45,466 records. From the shape concept should be familiar from the NumPy arrays. And I can pull, so going back to my movies object, now instead of pulling one column, I can pull two columns, title and vote average. This had IMDb votes or something like that. I'm putting it into a variable called title vote. But notice the syntax here. So like I'm pulling a key or an index from a dictionary or an array, the value I'm passing in is another array, saying I need these two columns. And what I get back is another data frame. So if I'm getting one column, I get a, where'd it go? I get a series. More than one column, I get another data frame. So from a data frame, I can get a data frame. And so since it's a data frame, I can do the same head function. There's a tail function. There's a whole bunch of functions we'll talk about. But in this case, since I only had the title and the vote average columns, that's all I get back. So I can see Father of the Bride Part 2 only got a 5.7 rating, which I'm surprised at because it's a great movie. I actually don't remember Father of the Bride 2. That's probably why it's a 5.7. Toy Story, 7.7. Jumanji, etc. So far, it seems pretty simple. All right, let's get to some fun stuff. And so, again, I have a shape attribute on the title vote, 45,466 records, but this time I have two columns. The first one, had I shaped it, I would have 24 columns. All right, now we can start looking at our data. So let's start filtering specific rows from a data frame. This is where we're going to start talking about other attributes that are available. So if we look at the code at the top here, we can select rows based on a conditional expression using a condition inside the selection brackets. So in this case, I want to get a list of all my movies that are rated greater than or equal to 9.0. So I start with my movies, and I'm selecting, it's essentially what this means is I'm selecting data where the vote average is greater than 9.0. And I'm assigning that, this returns a data frame, and I'm assigning it to a new variable called rated over 9, and I print out rated over 9, and it looks like another data frame. But if you'll notice, when I go over to my vote average column, if I scrolled through them all, they would all be greater than or equal to 9. Easy? Do y'all know relational databases at all? SQL queries, Oracle, Postgres, MySQL, that kind of stuff? Access, gross. Okay. A lot of these functions, to me, start translating to SQL queries. That's how I think of it in my head. So this is select star from movies where vote average is greater than 9. The same concept. And I just taught a database class like 10 minutes ago, so that's in my head. That's a blank one. I don't know why that one's blank. Let's see what the actual notebook says. So that's our 9. Oh, I guess it's nothing, and I didn't delete it. Well, I should delete it. All right, let's keep going. So the way this works is that filter parameter can be run by its own. And if you think about an algorithm, we have a collection of 45,466 records. If I run movies this greater than 9, it doesn't return the rows. Everything is index based. So if you think about a table in a database, everything has a primary key, like an ID, right? 1 through whatever. A data frame itself always has an index structure, an index thing it's not a column, but it's the index of the data. So every element has a unique index. Now, if I do a comparison like this to evaluate if those vote averages are above a certain number, the result is another data frame with matching indexes. And so when those indexes match, the value of the other data frame is just a Boolean, true or false. So when you think about, now I have 2 data frames, when I pull the query, I'm merging the 2 together. And they're matching on that index. So then I'm essentially filtering on that Boolean value that's created as a result of the comparison. So in that case, it's different than a SQL query, which is evaluating each row and returning the row. It's evaluating the rows, but setting a Boolean value, and then uses that to see if it matches the criteria. Now again, I have a new data frame, and I can run my data frame type functions. The reason Pandas is so fantastic and is used everywhere is that it's hyper efficient. So if you think about the original data frame we created with the CSV file, it was what, 8 megabytes of data? Something like that. I forget the number. I think it was around 8 megabytes of data. The CSV file itself was much larger than that. But when I start slicing this thing and pulling out different columns, it's not creating new data. It's not duplicating data into a new data structure. It's using the same source data in a hyper-efficient way, but kind of just giving you an alias to it. So that initial data frame of 65,000 objects with 24 rows is really the only data that's ever stored in memory. Even if I copy it or think I'm copying it by pulling out different columns and that stuff, it's always that same structure of data. Another comparison we can do, like before we were looking at things greater than 9 for votes. Here I wanted to find a specific movie, Toy Story. So again, I'm doing the movie's title equals Toy Story, which behind the scenes is pretty much creating a data frame with a bunch of Boolean values. And all of them would be false except for the one that has the title of Toy Story. And when that gets merged with the full data frame, I know which one has Toy Story. And so as an example of something else I might want to do with my data, I want to find all of the unique values in my languages. So I pull out a list of all of those languages. So that's not a unique thing, but that's okay, because now I have a function called unique. And I can use that unique function to get a distinct list of languages. So in a couple lines of code, if I went from opening that CSV, pulling out the languages, and printing out unique languages, that's only like 3 lines of code. Which if we did it manually in Python, it would probably be, more than that. But this is extremely efficient. Another comparison function is this is_in function. So instead of a less than, greater than, equal to kind of thing, I can make a list of movies, or a data frame of movies, I should say, where the original language is either French or Italian. I assume that's what FR and IT are. French or Italian. And so if the movie is in French or Italian, it'll be in this new data frame, and then I can print it out and verify that yes, they all look like they're French or Italian. So we've compared on equals for the name, or a greater than, less than with the votes, and now the is in to see if it's one of many things. Can't believe nobody's asked any questions yet. All right.
I was going to ask earlier if it has to be the same case. It has to be like, I'm sorry, my words are not coming to me.
You said it right. Is it case sensitive?
Yes. Thank you.
We will test it, but I think it is. It should be.
I would assume that it is, but I just want to make sure.
Me too. But we can't do that until I make sure I have those CSV files to play with. So using that unique function, I just wanted to make sure that all of the original languages were only French and Italian. So it worked. So checking the original languages, I can run a unique function, and I see that it's just French and Italian. Because when I have this list here, it's only showing me 10 items. And for all I know, there's thousands of them. And I'm not going to go through by hand just to make sure. So I'll use my super smart programming capabilities and run my unique function. So talking about cleansing data. There was a collection field, like what collection it belongs to. So Toy Story apparently belongs to the Toy Story collection, meaning there were more than one Toy Story movie. Grumpy Old Men, Father of the Bride, James Bond, all these like series of movies. And so the belongs to collection field can be null. If it's not part of a collection, it'd be null. So I have another function, not NA, which is not null. So I can get my list of movies in a collection by making sure that column is not null. Not NA, but I don't like that. What does not NA actually mean? I'll find it later. Okay. So subset of rows and columns in one go just using selection brackets is not sufficient. Oh, that's right. I don't remember what that means. So let's look at the code. Then I'll figure it out. So when I do I gotta get the definition of this one. Access a group of rows and columns by label or a Boolean array. Loc is a primarily label based. Okay, that's what I thought. So here, I only want the title field, or the title column, when I'm doing my vote average comparison. So when I get my titles, the resultant data frame is just the titles. If I want just the titles, the vote average, and the budget, I will get just the title, vote average, and budget. So now I'm starting to add optional parameters to I'm using the LOC function based on the data frame aggregation, or what's the right word? The comparison? Remember that second data frame of Boolean values? So that second frame of Boolean values is the first parameter to the LOC function. The second parameter is a list of columns. So it's filtering and pulling out the specific columns that I need and putting it into a new data frame. Here, I was trying to find movies that were greater than 9, vote average is greater than 9, and movie budgets that were greater than 0, and returning the title, vote average, and budget. So this AND operator we have not seen. This is a bitwise AND, meaning it's looking at 2 bits of data, and if they are both true, it becomes true. If they're both false, it becomes false. So because these are, the Boolean expression is a single bit of data, bits, bytes, etc. So this AND is saying if this bit and this bit are true, then I want to get the movie. So I'm stringing multiple comparisons together. And so I'm trying to get the title, the vote average, and the budget. Now the problem, I got a big error, as you can see. So if I look through that error, well, I don't think it was all in there. Let's see if I can, let me find this data and run it.
Notice in the last slide that all budgets were 0, so there can't be any that are greater than 0.
Oh, were they? Oh, in that case, they are all zeros. So it should return null. But let me get that data. Let me start at the beginning and find all my data. Oh, it's right here. Download. Of course it's slow when I'm doing it here. It'll get there. Promise. But let's see if I have that error up in my notebook. Here we go. If you look down at it in the end, I have a type error. Oh, that's the end of my slides for that part? Lame. Type error, greater than, not supported between instances of string and int. Which tells me that either since we didn't have a problem with the vote average before, and it tells me my budget column somewhere has a string in it. For whatever reason. I don't know what the value is or why it would be a string. But I think we should try to find it. I think we can find it. Okay, the data's downloaded. Move it to here. Unzip archive. Movies metadata is done. That's the important one. So let's clear all this and run through it as if we were running it. How do I do that? Restart and clear. No, I just want to clear the output. Code. Is that the one? Restart. That's fine. Whatever. Restart. There we go. Okay. Import pandas. Movies equals PD read CSV movies metadata CSV. It executed. You see how fast that was? That's pretty darn fast. To read 46,000 records from a 33 megabyte text file. That's pretty cool. All right, so movies, list of movies like we thought. Head, data types. Let's look at the data types. So what was the one I was trying to do? Budget? Is that right? What is the budget data type? So they have an object, which means they couldn't determine what the budget data type was. How can we find the unique values in that budget column? Anybody remember? Yes, so if I do movies, budget, dot unique, they're all strings. Okay, they couldn't cast them as are any of them not integers for x in print x. Now they all certainly look like integers. So any of y'all want to be a data analyst for your job? Maybe? This is data analysis. Jaleel, no. Anybody ever talk about doing machine learning, artificial intelligence? This is data analysis. Same thing. Ah! That doesn't look like a number. Let's figure out where that is. So that's the only thing I've got so far. So if I open this file, that's the only instance of this. So this tells me that this line, there's something wrong with it. I don't know why. I'm just going to delete it because I just want to show the code working. So let's go back and reload that data. And let's get our data types again. And our, was it budget? Why did I miss it? Budget, still an object. Crap. Try int x except print is not an integer. I did delete it from the CSV file because I'm being lazy. Ascending and descending, yes, I think we could do that. Even though there's strings, that would still work. But I'm lazy, so I'm just going to do it this way. What I'm doing is, for every line in the file, I'm going to try to cast it to an integer or convert it to an integer. If it breaks, print it out. So it looks like I got 2 more of these. So I'll edit that again, find that in the file. Rune belt, okay, cool, bad data, delete it. Next one. Bikini contest, we don't want to talk about that. Delete. So I deleted the bikini contest. So now, let's see what happens. Oops, what did I do? Okay, I've read, it's reading the CSV file, or what did I do? I have no idea what, oh, I think it worked. Notice it didn't complain to me that time either. Movies, let's do D types. My budget is now an int 64. We cleansed our data. The better answer would have probably been to look at those 3 lines, and I have a feeling they're just offset because like one of the columns is a, I thought there was a URL in here or something, genre, homepage. Homepage is a URL. There's probably a character encoding issue or something, and it probably shifted a column, and I could have fixed it, but whatever. So I just deleted it. Now my data types for that budget look better. Now I have an int there. ID, now I have an int. Popularity. So that seemed to fix a few things. Yeah, adult is now a Boolean. No, I will not query that for you, weirdos. So now if I run this, I should get all of my, I didn't get any errors. Now if I look at head, belongs to collection, budget, true. See, now it's showing me true false over here. Oh, it might have been before as well, but it was a string before. Type titles. So run titles. Oh, whoops, gotta do that first. Original title is titles. Run titles. So again, that's all working well. In the end, I want to come back and see this. So now I should be able to compare my voting average to my budget, or look for voting average and budget and get the title, voting average, and the budget. Now this should work. And it did. Title, voting average, and budget. 1, 2, 3, 4, 5. There are only 5 things that had a budget. I bet you it's because of the budget. If I put an equal sign in here, I bet I'm going to get more data. Yeah, I got more data. Great movies.shape. Oops. Tuple object is not callable. Shape. What did I do wrong? Oh, it's not a function. That's what it is. So 238 movies had a voting average above 9 with a budget of greater than 0. I have a feeling the rest of those are nulls or something. Now I remembered, or maybe not remembered, that's not the wrong word. There were more slides in here. Where did my slides go? That's not my slides. I had some fun slides, so we're going to do this on the fly. No, we aren't. We'll just do it. Yeah, we will. Okay, here we go. Let's play. So I want that there. I want that there. Open CV. We're going to do some drawing. I love drawing with computers. I was wondering why we were almost done. It's only 7:45. There were like 15 more slides missing. Not OpenCV, Matplotlib. So we're going to look at a library called Matplotlib. We're going to get into data visualization. So let's go through some examples. So like NumPy, like Pandas, like whatever else we've looked at for libraries, Matplotlib is another third-party library. For your computer, you'll run the Anaconda environment, and you'll install the dependency NumPy, or Matplotlib. And it'll install like 300 dependencies, but that's okay. What we can do is we can start drawing things in it. So let's start with a bar graph. So let's look at this bar graph code. So I'm going to import Matplotlib. Did I have another? Did I put it in another notebook? I'm really mad that this is like missing. IPIB, that's the only one. Okay, whatever. We'll do it by hand. All right. I don't make it slides as we go along. So I've imported the matplotlib.pyplot library and renamed it PLT for plot. So if we look at a chart here, this is a kind of chart you would build in Excel or whatever. But if you have Excel and you try to load that CSV with 65,000 records and 24 columns, it might be a little slow. So we'll do it in here. So I'm going to have some labels. Men, means. Now these are all hard-coded, but we could calculate all this data as we're going along. Standard deviation. So these are all statistics. So if you imagine we came from a data set, I don't know what G1, 2, 3, 4, 5 are supposed to mean. Oh, here we go. This is an example of creating stack bar, parameters, For error bars and bottom, that's women. Okay, it doesn't tell me what this data means. Width, we're starting to do, so this is our data. The men means, women means, men's standard deviation, women's standard deviation. Width is going to start affecting our graph. And here's where I start my actual plotting. So Matplotlib pyplot has a function called subplots, which gives me a figure and an axis. So on an axis, I'm going to add labels, which is my list up here, G1, G2, 3, 4, and 5. My men means my width to specify how wide I want each of my columns or bars. Y error. Y error. What does that one mean? Oh, that's the black line here. Is the standard deviation, and I'm going to call that one men. So up here you'll see the key. That's not the right word. What is the right word? Legend. Legend is the right word. And I'm going to add another bar chart. Same labels. Women means data. Same width. Women's standard deviation as the error. So I'm doing a stacked chart here. So the underneath my women means, I want my men means. So men should be the blue on the bottom. So under my women is my men means. That's probably sexist, but I didn't make it. Shoot, I keep clicking on things. I'm going to put a label on my y-axis. I'm going to set the title of my chart. I'm going to add the legend. And then I'm going to show the graph. One thing I love about Jupyter Notebook is when I run this, it shows it right here. So I've plotted that data. So I can change colors and all that kind of stuff if I wanted to. I can change my widths to make them skinnier. All that kind of stuff. That's one example. Which one looks fun? I don't know what a broken bar is. I like drawing like this. All right, let's do this one. NumPy. So here I'm going to use NumPy to create my data. SciPy, which is a scientific Python library. Matplotlib plot, path, and path patch. Those are different ways of graphing things. And then I'm doing some math that I don't understand. Maybe y'all do because you're smarter than me. And then I'm going to do the same thing. I'm going to plot it. Now this plot's a little different because I am plotting a tuple of data, an x and a y value. So I have x equals r times the numpy cosine of t. T was a bunch of line spaces, so a list of numbers. And y was r times numpy sine of t. So I'm plotting this line. X is the cosine, y is the sine, to draw a pretty cool picture. Maybe. Why didn't it draw? Oh, there we go. So I drew that picture. Okay. So I can do a bunch of stuff. Now, what I want to do is figure out how to plot our data from up here, our pandas data. And I bet you there's a way we can do that. Matplotlib pandas data frame. Here we go. So I already have my Matplotlib installed. All right, in this case, I'm taking a series. I'll plot this one just to show what it is. Do you remember what the series object was we talked about above? How do we get a series object? One column from a data frame, yep. So looking at this, I am creating a series. And what are my values in that series?
Random numbers.
Yeah, a whole bunch of random numbers, 1,000 of them. Remember we talked about index being that primary key, the thing that's not really a column but is kind of a column? In this case, I am making a index of a date range starting at January 1st, 2000 for 10,000 periods. I have no idea what that's going to look like, so let's figure out what that's going to look like. So the way I'll do that, I will create a new cell here. I will do that and assign it to a variable, and I will print out that variable. Let's see what that looks like. January 1st, January 2nd, January 3rd. So it looks like it's 1,000 days. Another helper function to create dates. That's kind of cool. I won't need that again. So now so this, the letter TS means time series. So now if you think about this data, I have an index of a date, and the data is a random number. So then I am calling a cumulative sum of that data. Okay, well now I'm looking at this chart and it's not just going up. I would think if the random numbers were all positive, a cumulative sum would just go up, right? If they were all positive, yeah, but they're not. So is this returning negative values? Maybe. Let's find out. Positive, negative, positive, negative. Okay, cool. So a bunch of positive and negative random values. Cumulative sum is cumulative sum. And then we can plot it. Why does my graph look different? Anyone? Should my graph look different? Nobody? What? You can only see my graph. Oh my lord! What did I do wrong? Thank you for telling me that. Stop share. Share. Now I feel dumber than usual. Hey, why does my graph look different? Thank you, Caitlin. Random numbers. So you didn't see that I was copying and pasting this from the Matplotlib website. Awesome. Maybe you thought I was smarter than I am. No. Okay. So this is an example of using a Pandas series, which has its own plot function on it. If I didn't cumulative sum it, now I just get those random values. Let's get rid of this one. Can I clear this one cell? Clear. There we go. All right, so that random function gave us a bunch of random numbers. It looked like all seeded around 0, between -3.5 to +3.5. If I looked up documentation, it would tell me exactly what it's doing. Here is another example. See, I'm pulling it from the right side, copying and pasting it into the left, where it looks like I'm creating 4 random columns, but this time in a data frame. The first one was in a series object because it was a single column. This time it's going to be in a data frame. Oops, don't do that. But again, I want to see exactly what this function does. So I'm going to print out numpy random rand n 1000, 4. 1, 2, 3, 4 columns. Again, random values. So they like the cumulative sum, so I will use cumulative sum. I will figure and data frame dot plot. So I didn't have to tell it what kind of plot I wanted. I didn't say bar chart. I didn't say line scatter plot, whatever. I think it just kind of figures out that it is going to be a 4-series line chart because of the data. All right, so let's keep looking at stuff. Bars, histograms. So there's a kind parameter where I can tell it what kind of plot explicitly to use. That's kind of cool. Bar plots. So I should see a plot.bar, and then they're setting a color. I want to find an example of what would be a good. Ooh, I love histograms. A good data visualization for our movies data. What would be a good data visualization for our movies? IMDb rating by budget. Budget was crap data. Release date. Let's come up with an idea. There we go. So let's try our, give me 2 numbers, vote count and vote average. Equals my movies, and I want vote count, vote average. Is that the right syntax? I always forget. I don't think so. I'm so bad with syntax. You'd think I knew what I was doing. All right, so now I have 2 columns, or 2 attributes, 2 data points in my data frame, vote count by vote average. So looks like I can do a scatter plot. So data frame, so VCVA dot plot dot scatter x equals vote count, y equals vote average. So vote count by vote average. I don't know, does that tell you anything? I don't do statistics, so I don't even know if I couldn't tell you if there's a correlation or not. Let's see, there should be a correlation function somewhere in here. Hey. Autocorrelation plots are often used for checking randomness in time series. It's not time series. Do I have a time field? What does release date look like? Movies. Oops. Release date. Dot unique. There's a whole bunch of strings. If time series is non-random, if time series, so this says all time series stuff. I'm gonna find out if there's a way I can only get data out of my data frame if the string value looks like a timestamp. Yes. Pandas data frame rows with valid timestamp from string. Hey, we'll see how good we can get. To date time. Ooh. Ooh, ooh, ooh. Assembling a date time from multiple columns of a data frame. The keys can be common abbreviations like year, month, etc. If your data does not meet timestamp limitations, as errors ignore will return original input instead of passing errors. Course will force an out-of-bounds date to not a timestamp in addition to forcing. Infer date time format true can often speed up times of parsing if not an 80. Ooh, ooh, ooh. That might be good. So what would that look like? That would be, I already have a data frame. Well, they're doing a series, so let's do a series. Right, PD series, then the list. So here's my series. Dot to date time. Let's just try that. That's gonna break. Oh. What did I do wrong? To date time. Oh, okay. So it's pandas dot to date time. Then the series. Not a time. Okay. So now we're getting somewhere. So I have a series. I just... Oh, I can't plot that. Whoops. Pandas Add Series. What does that return? Okay, that returns a series, I think. That is a series. Okay, cool. Now, Pandas Add Series to data frame. Oh, here we go. Look at that. We're getting there. Data frame to movies dot append x series. Data frame or series like dictionary object. Okay, cool. Columns. Equals list. I guess it's a single list. Real date. Oh. Oh, that's the pen. That's the append. So I think I just added a column. Why isn't it running that for me? Run. Something's not working. I think I broke something. I hit restart and run all code. Revenue compared to rating. That probably makes way more sense than what I did. Is it running? Alright, it's running there. It ran there. It should be running in order. Ran that. Oh, it's running the Excel. Shoot, I need to get rid of this line. This would kill stuff. That was supposed to be an example. That toExcel function is actually a really, really slow function. I think it took like 10 minutes for it to run. Alright, so now it's doing stuff again. There we go. Now we're plotting. There's our types. There's our types. So here's our series. Oh, so it doesn't like this one for some reason. Oh, append adds to the end. That's not what I wanted to do. That's not what I wanted to do. Did I want to add? Get addition to data frame or other element. Angles, degrees, data frame. Okay, whatever. That's not what I want to do. But I like your example. Let's do that. Revenue to rating. Revenue to rating, yes. So stop. Die. That one's dying. Let's not do that. Okay, cool. So how did we do a plot? Okay, so if we took this plot and let's copy it. Vote count, was it revenue, rating,
Vote rate.
Is it vote rate? Okay. Yeah, that's where I got to go back and here we go. Vote average. So I was looking for vote average. Okay. So So vote average, I guess this is revenue, but I'm going to flip those. I want them the other way around. That goes there. So I want vote average revenue on my Y. Oh, no, that's not. Well, yeah, it should be the same graph. So as vote average goes up, revenue goes up into a point. So if I took out outliers, I don't want my movie to rate above a 7 or an 8. Otherwise, the revenue goes down. I'm not a statistician. I fully admit that. But you can see that we get some really fun data visualizations. And I never got to my date time fixing thing, so maybe I'll go offline and fix that later. But there's some pretty cool things. So if you go to the Matplotlib, well, that's the Pandas website. But if you go to the Matplotlib website, there are tons of examples and tutorials just to show you all kinds of data. Trying to see if anything jumps out as super cool. All kinds of statistics based charts, pie charts, scatter plot on polar axis. So that's kind of cool. But like some examples here, you can do image manipulation with Matplotlib. PyPlot is another library. Now we're getting kind of cool in here. Oh, now we're looking at heat maps. These look like heat maps to me. I love heat maps. They're some of my favorites. Image grids. Animation? Oh, we gotta play with that. Data generator. Okay, so I'm generating data over time. Set up my map. Function. And, okay, that's kind of cool. That looks too complicated to run through real quick. All right. Any questions about the Pandas stuff so far? At all? Whether it's the CSV import, the data types, the functions we have. There's a lot more analysis we can do of the data. Plotting is one way of doing that analysis, but for tonight, that's kind of where we'll stop as far as our analysis goes. But next week, we'll talk more about that, I think. So congratulations, we got through topic number 1 for the night. Anybody need a 5-minute break before we go to topic number 2? Nah. All right, let's move to topic number 2. I'll fix my slides, or fix this. Our second topic is going to be looking at APIs, or REST APIs. Has anybody heard of a REST API, or an HTTP-based API, or a SOAP API, or the phrase API at all? Not so much? Okay, got one. I've heard the phrase. What? My picture is not here. I'm very mad about that. Time to do some zoom drawing. So an API is an application programming interface. It can mean a whole lot of different things. What it will mean for us, we are building an interface between systems. So imagine we have our Python code. Imagine we have a database. If I needed to pull data out of my database, I can make a database connection, execute a query, and get back my data. Right? Seem reasonable? We don't know how to do that yet, and that's fine, but the concept, connect to a database, pull data. Now let's say this is my Python-based data analysis, data application. And we have to use the same data on our website. So we have a website. It wants data from my database, so it connects to my database, executes SQL, and gets the data back. Well, we've got data analysis. We've got a web application. Let's say that's our customer-facing web application. But now I need an administrative application. So my admin needs to be able to update, modify, all that kind of stuff. How do we do that? We connect to our database. We execute SQL. And we get back data results. Okay? So we have built 3 different applications, and they all connect to my database. Well, we were using Oracle because somebody convinced our CTO or CEO that they had to spend lots of money on our Oracle database. COVID happened and our budget took a dump. We no longer have budget to pay for our Oracle database. So we do a market research quickly and find out, okay, we can't use Oracle anymore. We're going to switch it to a Postgres database. It's really hard to write like this. I really should figure out how to use my iPad better. I can't even remember. See, I'm distracting myself too. Postgres database. That's not how you spell Postgres, but that's how I spelled it there. E. So when I change my database, what else has to change? Because my SQL queries are no longer compatible. I have to change my analysis database. I have to change my customer web application database. I have to change my administrative database. Us developers are really, really expensive. But I have to do this in like 3 weeks. So I have to hire a new team to make changes through all this stuff. What we've done is we have taken the details of our database and exposed it to multiple applications. And the reason we don't do that is, or we shouldn't do that is for a bunch of reasons. Like we have in development or software design, we have the concept of abstraction. We typically want to abstract layers of knowledge to only where it's applicable. So my database has a structure, it has a SQL interface, it has a version. That's very database specific. My application shouldn't know that. What I should have is an abstraction layer in the middle. So, Professor, how do we build an abstraction layer? Well, let's talk about that. Cancel. One thing we can do is build a RESTful API or an HTTP-based API, Application Programming Interface. Before we read what this means, I'm going to draw this a little differently. Oops. Draw. Ooh, squares. Admin tool. Web tool. Administration tool. All uses a common API that connects to my database. So now we have one application that speaks SQL. One application that knows the details of how my database is built. My web application interacts with my HTTP layer, my RESTful API layer. My user, external, my administrative, my analysts, they all start now, they've abstracted the details of the database by going through a common layer where if I have to change out my database engine, I only have to change it in one small part of my application instead of across all three applications. So in HTTP is the protocol. Has everyone heard of HTTP for like the web browsing, curl, or gets, posts, puts, all that stuff? So HTTP is that protocol. Every programming language in the universe speaks HTTP. REST is a little different. We'll talk into that. But the idea is REST sits on top of HTTP. We are building a client-server model. So our client is our different applications. And our server is this middle API layer. We'll use different... this layer in the middle is supposed to be stateless. It's not supposed to remember anything. It's supposed to basically interact with the client or interact with the database on behalf of the client. The client makes a request to the server. Then the server makes a request to the database and returns the data back to the client. So it's kind of a man in the middle here. All right. Clear. Move on. Come on. I don't want to get too detailed on what does the HTTP protocol look like, but I want to pull out some key points. So a client makes a request. They make an HTTP request to the server, and the server gives back a response. So in this case, this client, this is the HTTP protocol. This client is making an HTTP GET request to the server. The URL is a /, so it's like the root of the web server. This is small, I'm sorry. And the protocol version is HTTP 1.1. The host name in this case is example.com. If this were VCU, it would be vcu.edu, etc., google.com, whatever the host name is. Then the response looks like this. The response tells you the protocol, HTTP 1.1, the status code, success, failure, all kinds of stuff. HTTP 404, everyone knows means not found. 200 means success. Then it gives some metadata. In this case, I'm giving a date, content information. An important part here is the content type. This response is a text or a HTML response in a text format. More metadata, what server it came from, all that kind of stuff. And then what's called the body of the response is, in this case, is the HTML of that page, of that web page. Or if it were that API, it could be a JSON structure representing the data in the database. HTTP post is very similar, but the verbs mean something. So get means I want to get something from the server. Post means I want to give the server something. And so the protocol is slightly different. HTTP post, a URL, version, host, all the same things. But in this case, my post has a content type as well. In this case, you don't have to know this all that much, but the content type is a www form URL encoded. And the size of the request is 27 bytes, and this is the format of the request. So a key value separated by an ampersand, key value. So my server can look at things like field 1 and get the value, field 2 and get the value. Then the response looks like any other HTTP response, which could be HTML, it could be XML, it could be a JSON structure. In this case, it's a quick JSON structure. Everybody good? Good. So, how do we do all those requests and responses? From the request side, we all use a web browser every day. And you can type in your address bar. And when you type in your address bar and you press enter, your browser is making an HTTP GET request to a server. It's always a GET if it's from your URL browser address bar. Some websites have a form in them, like a login form, username, password. They'll have a HTTP post command usually to a server to post your username and password, and you get back your logged in session or whatever. Curl is a command line application or a Linux library as well, or a C library, but it's a command line application. You can use curl on a Mac, on Windows if you install it, on any Linux machine, to make HTTP requests. So curl https google.com, and I get the response back, the HTML from that response. I can also make an HTTP post, bunch of different ways to do it, but in this case a -d parameter says I want to send data to the server, making it an HTTP post. I'm going to make sure the server knows I'm sending it a JSON structure, and here's the URL I'm sending it to. So here I'm trying to log into example.com by passing a key with the value of value. So there are many, many different ways we can make these HTTP requests. And so when we look to Python, everybody come back, because now we're at Python again. We have a library or a package called requests. HTTP requests. Great, get it? So we have a requests library. There is a built-in Python package to do HTTP interactions, but it's awful. The interface is awful. It's really hard to use and really hard to understand. So what some super smart and awesome developers did is they said, well, this API sucks, or this package sucks. I'm going to make a new one. And really funny, they called it HTTP for humans. Go away. Hide. Nope. Hide. There you go. Requests, HTTP for humans. So looking at this code, I use the requests library. Amplify that a little bit. I'm making an HTTP GET request to this URL. In this case, there's also authentication information, but ignore that for now. But it's that simple. Requests.get the URL. Then my result, I see I have an assignment to an R variable. I have things like the status code as an attribute of that object. And HTTP 200, like we saw earlier, the status code is an integer with that number representation. There are response headers I can get from a dictionary-like object. I can get the encoding. I can get all the text that was responded from that HTTP request. And if it's JSON, I can just call a .json function, and the return is a dictionary, or whatever the proper JSON structure is. In this case, it's a dictionary. So let me show you why they did this. This is just for fun. You don't have to worry about this too far. Python 2.7 URL Lib example. Here we go. Okay, URL Lib. I'll make that bigger. URL lib2.url open python.org HTML equals response.read. Well, that's reasonable. But now I've got to URL encode values. I'm going to pass open read. I don't know what I'm doing here. It looks like more values. I'm URL encoding things. I'm building a URL by hand. Like, this is awful. This is a really bad interface. So I have to take my dictionary of data, use a URL encode function of that dictionary to get URL values. The URL values is a string that looks like this, name, etc. Then I have to get my base URL, add a question mark, add the URL values, and then I can make that HTTP request. Compared to the requests library, Ba, 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 ba. Here, I have payload, which is a dictionary. I'm making a HTTP request GET, and I'm passing the payload as parameters. The library does it all for you. It may not look like a lot of difference, but I'm telling you, this is so much simpler, especially if you do this a lot. Anyway, that goes to that library. So the requests package is really, I don't know any applications that don't use it if they've got any sort of interaction with the web or HTTP. I can make an HTTP post, and I can pass in tuples, I can pass in a payload, and again, I can get back the text from it. So these are all the client-side things. These are, how does my client application make the request to the server? So it's pretty straightforward. Any URL here, if you have to put a port in here, just like you do in your web browser, you can put a port in here, like host : port number. You can do all kinds of stuff. So if we talk about the server side, where we're responding to those HTTP requests, going back to my ugly drawing, the thing in the middle, if we were drawing that ugly thing in the middle, that's the server. So there's another library we'll use called Flask. There are many, many libraries in Python to help you do this. Flask, in my opinion, is the simplest one to understand. So we're going to start there. So we can use the Flask package to create a web server. So if I look at my 5 lines of Python code here, I'm importing the Flask object, class, from the Flask package. I'm creating a variable called app by calling the Flask constructor, passing a name to it. The name is the string representation of the file that this code is running in. Then you'll see something we haven't seen before. And I'll come back to that. After that thing we haven't seen before, we have a function, just like any other thing. This one's called hello world, and it returns a string. So what this thing here is called, it's an annotation. So it's code, but it's not normal Python code. Annotations start with that ampersand. Ampersand, is that the right word? Or is that the ampersand? The at symbol. At, and in this case, app, because it's related to this Flask application, .route /. So thinking of web browser, google.com, you type in google.com in your browser, it makes a request to the root of that web server. So I'm saying if something makes an HTTP request to the root of my server, respond with hello world. Then I can run that server by setting an environment variable, Flask run. I can pass a host parameter. I'll tell you why we did that later. And now I have a web server that executes Python code. So let's make that happen. Python 3.7. This is my equivalent of doing Anaconda. So I'm just doing a quick pip environment, although it's not terribly quick apparently. Maybe. Oh, it failed. Oh. I hit Control-C. Stupid me. There we go. Alright, so now I have a virtual... Oh, failed to create. Env Python. Which Python 3. So in Anaconda, you can go in and create different environments. I'm doing the same thing with a different tool called pipenv. Whoops, not run. Pipenv shell. So now I'm in that virtual environment. I'm going to install the Flask library, and I'm going to install the requests library, just like you will do in Anaconda by going to the environment and managing the dependencies. So I'll run that, and it will download and install my dependencies. And while it's doing that, I'm going to grab this code. Okay, I'm going to make a run file. I like run files. They make my life easier. Then I want to run my, what did I call it? Hello.py. Hello.py. From Flask, import Flask. App equals Flask name. App route returns hello world. So now I can run that script, and you'll see I got the same stuff saying my server is now running on port 5000. So if I take this and I split it horizontally, I can make a curl request on the HTTP protocol, localhost, port 5000, / hello world. So my code ran. That's kind of cool. So if I go change my Python, and I want to do something cool like name equals Chris, I can return a formatted string, hello, name. I'm gonna add a new line character for fun. Oops. Run it. HTTP request, hello Chris. So I went through that quickly, but I now have Python code responding to an HTTP request in 3 lines of code. Like, I defined a function. It abstracted everything about the HTTP protocol. I don't care about that. I don't care about the request content type. I don't even care in this case if it's a get or a post. It just doesn't matter. It abstracted all that stuff from me. So I have created an API. But we can do more. So the first one we saw was that root or that index page. Well, let's add another root to it, route. Route. Let's use route. So I'm going to add another route to it. So let's get rid of hello world. And I'm going to make a route at the beginning, or the top level, and then a different route for hello. So I can write that. I can run that. Now I can curl HTTP localhost 5000 / root, and I get the index page. We're seeing this percentage sign because I don't have a new line character at the end of my string. So in this case, I don't like those, so I'm going to add a new line character to both of those. Run it again. And there, now I get my root route, because that is the root. So my root route returns index.html. And if I add the word hello at the end, it'll execute and return hello world. So again, looking at that code, this mapping of /hello matched my HTTP request. And when I passed hello, it returns hello world. When it doesn't, when it matches the root route, it returned index page. So if we think about this, going back to the concept of building a client application, a server application, and using a database. This Flask application sits in the middle. This is the server application. Curl, in this example, could be a Python file. Could be a Python application using the requests library. Because all that does is makes an HTTP request. So let's do it. I called that one hello. Whoopsie. Desktop projects. Info 450. Week 11. Flask. So let's. Oh, did I not do it in there? Oh, I did it up here. My bad. We'll make a client.py. And we'll use that requests library. R equals request.get HTTP localhost 5000 / hello. Print r dot text. Okay, 2 lines of code here. Make the HTTP request, HTTP get, and then print the text. So now I need to get my pip environment right. But now I can run Python client.py. Oopsie, and it didn't work. Oh, because this is not running. And I run my server. Now make my client request. So you see down here at the bottom, it printed out hello world. So my Python application got the text and returned it. My server also gave me a nice little output, a debug output that said I got an HTTP request to hello and responded with 200. So I can do my client, I can do another line of code in here and get rid of hello. And I should see hello world in index page. Any questions about this? So what can I do on the server side in the Flask application? What can I do with it? What kind of data can it access? What kind of actions can it take? This is where I sit in very comfortable silence. Yes, Flask is the server. What can you do on the server? And you're not allowed to say connect to a database because I already gave you that one. The longer it's quiet, the more clementines I can eat. The Flask would receive inputs from the customer or Python or the admin. Yep. But I'm not talking about the example from the beginning. Think about anything. Think about where you work. Think about your day job. Think about what you do for fun. What could you make a web server do? What could your Python code do? Nobody? Nothing? File transfers? Yep. I'm going for a simple answer. Anything. Your web server can do anything. Anything code can do, you can have happen as a result of your HTTP request. So, turn off a light bulb. Play a song. Turn off your TV if it's connected to stuff. Hell, send a letter, send an email. You can do anything. Because code can do anything. You can have an HTTP request, connect to your Flask server, that opens a CSV file, process it, and finds unique values for original language of your movies and return it. You can do anything. But the cool part about this HTTP request is that the client, the one making the request, has no idea how the action happened. It doesn't matter. It doesn't know that it connected using the X10 protocol to turn off a light bulb. All the client cares about is that the light bulb gets turned off. Because tomorrow, you'll buy another type of light bulb which you control through a different protocol, and you don't have to change your client. So this is the area of work that I do every day. And that's why I really like software. I like technology. I like web applications because I have a nice interface over HTTP to do whatever I want. All right. We saw the HTTP parameters in our request string. You know, the question mark, key equals value, ampersand, another key equals value, right? We can do that in Flask. But if we want to start talking about the concept of a RESTful API, the RESTful part stands for something stateless, something or other, transformation, entity, RESTful entity, stateless transfer, something like that, whatever REST stands for. The idea here is instead of passing an HTTP parameter, I can use my URL to embed parameters into it. So, as an example, I have 3 new routes in here. I have one route with a username. And then using these less than, greater than symbols, I'm specifying that I am going to call whatever that next segment of the URL is as a variable. In this case, the variable username. And this annotation then knows I'm going to have a variable called username, and I'm going to pass it as a variable username to my function. So I have a route user/username, show user profile function that takes the username as a parameter. And in this case, I'm going to use it to just return that value. The next one, I have a post URL, not an HTTP post verb, but a slash post URL. And now I've added a little metadata to the parameter saying it must be an integer, and I'm going to call it post ID. Excuse me. As I die. That's what I get for eating and talking. Juicy clementines. All right, so let's take this code and put it into our Flask app. Flask app. Whoops. What did I call it? Hello.py. Let's add a couple new routes. So, I don't know if this is a new, if this is a library. Markup safe. Let's see if I have to install that. Pip env install markup safe. I don't know if that's its own library or part of Flask, but let's try. Okay, it installed, or was already installed. So let's look at these routes again. User/username, post/integer, path/path. I don't know what that means. Let's figure it out. I'll put it over there just to show you. Run. I'm going to use curl this time just so I can stay here. Curl HTTP localhost user Chris. Hello, user Chris. George. Promise I'm not dying. So you can see whatever is in my URL gets passed into that user profile function. Whoops. Post ID. http localhost :5000 /post /1234. So we see when that's an integer, it must be an integer. Anybody want to guess what happens when it's not an integer? Does it go to that function? Let's see. I don't know. I got an error saying a requested URL was not found on the server. HTTP 404. That's what I expected. But if it's an integer, it'll go to that function. Now, I seriously don't know what a path is, so let's find out. Okay, I liked that. Just a bunch of random characters. I liked numbers. Didn't like a / underscores. Okay, now I gotta find out what a Flask is. Flask path. Routing. What is a path? There we go. Like string, but it also accepts slashes. So that is the path type. A UUID accepts UUID strings, float, int, string. So I can define my route to be any of those things. Over a window. All right, come back here. So does everybody see how I can get data into my Flask application? Yay? Nay? One camera person is nodding. The other camera person's eating, and that's okay because I'm jealous. Any questions so far? All right. So that is the lesson for tonight. Welcome back to homework. But this one's going to be a little different. This isn't due next week. But I highly suggest you do it. It should be pretty straightforward based on the code we wrote tonight. I need you to write. We're going to start building stuff. We're going to start building kind of a mini final project. Because we only have like 3 weeks left of class. This is really, really weird. Today's the 5th, 12th, 19th, 26th. Then our final on the 3rd. Like, this is weird. And I think one of those is Thanksgiving. Right? Yeah, one of those is Thanksgiving. So I think we only have 2 classes left. That's crazy. I'm having fun. Hopefully y'all are having fun too. Sad face. Totally agree. Okay. Anyway, so thank you for reminding me of Thanksgiving, because I totally forgot about that. Turkey Day. But here's what we're going to do. We're going to start an application, or a couple applications. And we're going to learn a few things in the next 2 lessons to make a mini project. Now realizing there are only 2 weeks, it'll be minier than I planned. And that's okay, because I'm having fun. So create 2 Python applications in your GitHub repository. One called a client and one called a server. And just to make sure you get it right, have your client make an HTTP request. Well, first, make your client get some user input and put it into a variable called name, or whatever you want to do. Make an HTTP request to the server you're about to create, passing in that name to your server. So your server must accept a path, hello, and another path parameter called name. And then your return value must be a dictionary with the key hello and the value of the name URL parameter. So in the examples, or in the Flask application, I only returned strings. but you can return a dictionary. Let me show you what it does and why I think this is now where we start making some awesome code. Dictionary. Oopsie. Oopsie. Dictionary. Dictionary. There. curl/v gives some verbose output. HTTP localhost 5000. Oops. Connection failed? Oh, it tried multiple addresses. Okay, cool. Let me change that to not be localhost because I'm being verbose. There we go. Okay, I made an 8. So this verbose output, it's telling me some debug stuff. It's trying to connect to this URL, this IP and port. And then it says, hey, I connected to that IP and port. Then it shows me the exact HTTP request it makes. Get /HTTP version 1. User agent is curl because I'm using the curl application. And my response, I'll accept anything. Any content type, any encoding, etc. Here's the fun part. And I'm totally lying. Oh, no, that was the root. Okay, good. Whew. Okay, so the root returned the string index page. And the content type, this is the important part. The content type is text HTML. See that? My server responded with something I can interpret as HTML. It's not really HTML, but that's what I can interpret it as. If I call my dictionary route, and remember the return value for my dictionary function is a Python dict dictionary, my content type on the return is a JSON structure. So the web server knows, Flask knows, if I return a dictionary or an array, return it to the client as JSON. That's going to be super critical down the line. So that's why I want you to return value must be a dictionary with key hello and the value of the name that was passed in. Easy enough? I'm going to put that run.sh, hello.py, and client.py, link to it from the slides. So this should be pretty easy. The hardest part is going to be getting your environment your environment dependencies with Flask and requests. But Anaconda does that for you. So once you do that, this should be a 10-minute homework assignment. The next one's going to be hard. So get ready. Everybody good? Two nods. That's all I get. All right, folks. I'm going to stop recording.